Hey everyone, hope you're all having a good break. Um, in this video, I'm going to quickly just go over each of these four problems. I'm not going to solve them, but I am going to set them up. I'm going to let you do most of the hard math work for you to do. All right, so let's start. First one, 8 books, each 4.3 centimeters thick with the mass of 1.7 kilograms, lie flat on a table. How much work is required if you wanted to stack each one on top of another? All right. So if you got your books, we are assuming that they're all the same size. Screw you for laughing at my drawings. First, we know that the mass, 1.7 kilograms. The thickness, I'm going to leave this as delta x. In a minute, it is 4.3 centimeters. Make sure that you convert that to meters. I'm going to let you do that. We need to find the amount of work it takes to stack each one on top of another. So first place you got to look at, oh, that's a weird W, is work is force times displacement times cosine of theta. I will let you think on what should theta be in order if you're applying a force up and the displacement is also up. What would that take? What would that angle need to be? First thing you got to think about, your force. You got to think about what minimum force are you going to lift up with in order to lift this book, to do work on this book. And it turns out that you want to find the weight of each book. Now this is a little trickier. So you have to find the total amount work done for each one. The first book, oops, I called it 0. The first book is actually going to not be any work because it's just going to lie on the table. Now you have to figure out, well, what is the work of the second book going to be, and so on and so forth. I will give you a hint. You don't have to worry about all the different distances you go from. Like if you're taking this book and you have to move it all over there, you just have to worry about your vertical Y distance. Your first vertical Y distance is going to be the thickness of one book. And then I'm going to let you figure out, well, how would you go ahead and solve for 2 books or 3 books or 4? All right, for the second problem, an 88-gram arrow is fired from a bow whose string is an average force of 110 newtons. On the arrow over a distance of 78 centimeters, already convert it to meters. Whoops. Okay, what is the speed of the arrow as it leaves the bow? This arrow gained energy. How do you gain energy? You have to do work. Once you can find the amount of work you do on the arrow, is there a way for you to find the kinetic energy that it gained? And once you know that, is there a way for you to find the speed of the arrow? Huzzah! All right, the next problem is just kind of a unit converting problem. Electric energy units are often expressed in form of kilowatts. Show that 1 kilowatt hour is equal to 3.6 times 10 to the 6 joules. Yeah, so if you check out your power bill, your electricity bill, they charge you in kilowatt hours. So pretty much you take a kilowatt times an hour, and you pretty much just need to convert this into joules. Where I would start is remember what all the SI units are. Kilowatt is a form of power. Hour is a form of time. So essentially you need to convert kilowatt into whatever the SI unit is for power, and then convert hours into whatever SI unit is for time. And then you should hopefully get this for your answer. Huzzah. All right, so the last problem is a bit of a doozy. As you can see, I've kind of laid out all what we know already and what we don't know. You got 0.84 kilogram wood block is firmly attached to a very light horizontal spring with that spring constant as shown below, actually to the right. Whoops. It is noted that this block spring system, when compressed 5 centimeters and released, stretches out 3.3 centimeters beyond equilibrium position before stopping and turning back. What's the coefficient of static friction? The amount of energy. So what I want you to look at is you have some energy when it's compressed at 5 centimeters. You have some amount of energy after it is stretched out 3.3 centimeters. That's ugly. Let's look at that. 3.3 centimeters. And so if you had to guess, these don't line up. They're not the same amount of energies. And so we know that, something happened. And what happened is energy was lost. And so the big question is, can you find a way to figure out what is the amount of energy lost between the first part and the second part? Once you know how much energy is lost, you would have to relate that to the force of friction and think about how would you calculate the things you needed if you knew the amount of work that friction did. Gonna let you think about that. If you have any further questions, please send me a message on Remind, or you can send me an email. I hope you all enjoy yourselves. You will have a test on Friday. Happy holidays and have a good one.